Hi, my name is Caroline Castensmith. I'm in Lab X18, and this is my Lab 2 charge tapes. This lab report will have four main parts. First, the introduction, where I'll go over the purpose, the models I used, and the results. The second being the main physics fundamentals that I used in this lab, and then the third being the experimental and computational model from both Lab 1 and Lab 2, and the fourth part being the reflection questions. In this lab, we will conduct the same experiment from Lab 1 and then put that data into a computational model. Using GlowScript, we will use data from the previous lab to demonstrate and visualize both the electric fields and electric forces, along with calculating their specific magnitudes and a more realistic calculation for the charge of the tape. Using the GlowScript model, we found that the magnitude of the electric force was 3.373 times 10 to the 5th newtons. The magnitude of the gravitational force was 1.962 times 10 to the negative 3 newtons, and the line charge calculation was 2.518 times 10 to the negative 8 coulombs. Before we begin, there's a couple fundamental physics principles that I've used in both labs 1 and 2 that I want to go over before we start. Those main principles being Coulomb's law, the electric field calculation, force on a charged object, gravitational force, and how charges interact with each other, along with constants listed at the bottom. The experimental model that we used in this lab is the exact same one that we used in Lab 1, where we ended up charging two pieces of tape, setting one of these pieces of tape across two still objects, and then moving the other piece of tape close enough to the first piece of tape until the first piece of tape moved, and then recording this distance. The assumptions and observations for this lab are very similar to the assumptions and observations from Lab 1. We're assuming that each U-tape has the same net charge, but what's different in this lab than in Lab 1 is that we're treating each piece of tape as if all of its charge was spread out over the length of the tape. As for observations, we know that both pieces of tape were positively charged since they were attracted to a negatively charged pen. We know that they were both positively charged because they repelled each other. And then we know that the first U-tape started floating when the second U-tape was 0.028 meters away, which I averaged after 5 trials. From doing the math, we know that the length of the U-tape is 0.2 meters, the mass is 0.0002 kilograms, and the distance between the two tapes was 0.028 meters averaged after 5 trials. Finding the gravitational force, we got 1.962 times 10 to the negative 3 newtons, and then treating the tape as point charges, we got that the charge of one tape was 1.307 times 10 to the negative 8 coulombs. We know that the total number of deficient electrons was 8.17 times 10 to the 10th, and then we've got the number of atoms being 5.2 times 10 to the 17th, therefore the ratio being 1 atom to 1.57 times 10 to the negative 7 electrons, or 1 electron to 6.36 times 10 to the 6 atoms. So in Lab 1, in order to find the charge of the tape, we treated the piece of tape as if it was a point charge. In this lab, we wanted to treat it as if it was a line charge, with all the charge being spread out across the whole piece of tape. In order to do this, I found the electric force equation and set it equal to the gravitational force calculation that I had shown earlier, and I solved for Q, and then plugging in all the values into that equation, I got that the actual charge, if treated as a line charge, was 2.518 times 10 to the negative 8 coulombs. Then, by using GlowScript and the coding template provided, I was able to plug in all the correct values where needed in order to compute the magnitudes of the electric force and gravitational force. I was also able to create this visualization of both forces and what the electric field of the tape would look like if we could see it, based on it being a line charge and not a point charge. Now, what if we had modeled each of our tapes as a single point charge like in the previous lab? Well, in the previous lab, I calculated that the charge of the tape, if we were to treat it as a point charge, was 1.307 times 10 to the negative 8 coulombs. And in this lab, I calculated the line charge calculation to be 2.518 times 10 to the negative 8 coulombs. This is a 48% difference between charge calculations. Why do these estimates differ? Which value is more likely to be closer to the real value, and why? Well, the line charge calculation is more accurate than the point charge model. This line charge model factors in charges being spread across the tape by separating the tape into pieces and adding all of their charges together as if we were integrating it. Because it is more realistic to spread out the charge across the tape, this model is going to be more accurate than the point charge one. Once again, my name is Caroline Castensmith. Thank you guys for watching my Lab 2 charge tapes. See you next lab.